Welcome to the first in a three-part demonstration series where I'll be looking at changes that I've seen in the design of bathroom ventilation in residential apartments over the last 10 or 20 years. In this first demonstration, I'll set up a basic old one-bedroom apartment in CONTAM with a fairly typical exhaust from a single bathroom that relies on leakage through the apartment's facade to replenish the exhaust. So, to start, I'm going to prepare a simple schematic plan, which doesn't need to be to scale, of a basic one-bedroom apartment with a single bathroom. Start off with the overall floor plate, add in a bedroom, and next to that we'll have the main bathroom. I'll define some of these spaces quickly. So we've got bed 1, 15 square metres, bathroom 1, give it 10 square metres, and the remaining space we'll just call living, dining, kitchen, and so that's 45 square metres. Okay, now we'll add some details for the surrounding enclosure. We'll put a door on the front, we'll put a window in the bedroom, we'll put another window on the side of the living room here, and a balcony door. Then we'll need to identify some leakage through each of the facades, so we'll just pick a spot generally over here for the whole living space. The wall of the bathroom and the wall of the bedroom. Probably should put some doors inside as well. Door to the bedroom, a door to the bathroom. Okay, now I'm going to be defining these elements based on some leakage data that I prepared beforehand. These elements aren't included with the CONTAM software. You'll need to develop them based on your own research. Have a look at my previous video to see how this can be done. Okay, so for the door, we'll just say it's a closed door, old type of closed door. Internal doors, we'll have open doors. We've got an open door in the bathroom for the purpose of the modelling. We'll just have some leaky old windows here. Window old, and a leaky old balcony door. Balcony old. There we go. Alright, for the flow elements here, we'll have the facade, so we'll just have an old facade, and I'll set the length of that facade to be 12 metres in total. This one we'll go with an old facade, and I'll set it to be 2 metres, and for the bedroom we'll go with an old facade, and I'll say it's 3 metres of external wall. Okay, time to add some of the ventilation, so we'll put an exhaust point here. We're going to put in a return. Now, I'm going to be setting this up based on the minimum requirements of 1668 Part 2, Australian Standard 1668 Part 2, for a domestic dwelling. So, create an air handling system here. I'm just going to call it exhaust, so we can gather all the exhaust data. I'm going to put 25 litres a second of exhaust, which is the minimum amount required by AS 1668 Part 2, and then we can run this and have a bit of a look at what happens. Okay, so the imagery here shows us some of the results, and have a bit of a look around. So we can see the exhaust here, 25 litres a second. We can see the main entry door. We've got about 4.5 litres a second coming under the entry door. The main balcony door, we've got about 5. Through these windows on the side, we've got a little bit here, a little bit there, a fair bit leaking through the facade construction. So we can also look at the pressure drop to outside, between inside and outside. So through all of these elements, all the pressure inside here is relatively similar. We've got about 0.7 pascals. So occupants aren't likely to notice too many problems with such a low pressure drop. But over the years, lazy designs led us to increase the exhaust rates and corresponding energy waste, rather than simply arranging the exhaust appropriately relative to the enclosure's source of makeup. So let's have a look what this does. Let's increase the exhaust here to 50 litres a second, which is a very common number used in design now. Say OK, rerun the simulation, and have a bit of a look around. So we can see that we've still got air flowing through all the similar sort of leakage paths that we had before, but we'll see the leakage across the facade or through the building envelope here is about 2 pascals. So probably not going to notice too much of a problem with that either. So design really progressed like this for many years. So thanks for watching. Now have a look at the second part in the series, where I have a look at what happens when we add some more enclosures, requiring some more exhaust from the apartment, and tighten up some of the leakage through the doors and the windows in line with what I see as being fairly commonplace for design of current construction. As you see through the rest of the series, this hasn't kept up with changing construction. In the remaining parts of the series, I'll look at the effect of changing building construction and exhaust design, highlighting where things are going wrong, and outlining some possible solutions that designers should consider. Thanks for watching.